So say that again. It's really hard to delete.
Make this new matter in the lab. So we said accelerators, detectors, computing. The World Wide Web was born at CERN because we push computing to the limit, because physicists around the previous accelerator to the LHC lab, they needed to share the data from anywhere in the world. And there was no universal language that allowed you to go easily on the internet and to put anything you need, all the kind of data you need. So Tim Berners-Lee, a very young physicist at CERN, he was 28, he created the HTML language, the URL, Universal Resource Locator, and the WWW, which was the winning system to be able to put anything you want easily on the internet. Born at CERN, made public to the world, and enter the world, and now we cannot do without the web. This is the grid, the worldwide computing grid, because with DLHC, not only we need to share information, but we need to share computing power and storage power. So in spite of 2 big supercomputing centers here on site at CERN, this is not enough to process the 40 million collisions per second of the LHC. So physicists had to invent the grid, the worldwide computing grid, the LHC worldwide computing grid, which is the same principle as the web applied to the sharing of processing and storage power. And so in the grid, we have 250 computing centers, all connected, that get the data from the LHC and make them available to the physicist. As I said, what we do in the LHC is understanding the primordial universe. This is the history of the universe in 13.8 billion years. Each image in the rounds are scientific images. This is from the last one today is from the James Webb Space Telescope. We have Hubble here, and we have the Planck telescope when light came out of the plasma, when the universe was 380,000 years old. It was pretty young, because today it's almost 14 billion years old, but it was still not the initial universe. So before light existed, there was no electromagnetism possible. The photons were trapped inside the plasma at 100 seconds age of the universe. And this is studied at CERN in the quark-gluon plasma by the ALICE experiment, but also ATLAS and CMS. And with ATLAS and CMS, we studied the very beginning, the Big Bang, but 100 billionth of a second after. So this is the closest we've been to explore quarks and electrons separated from atoms. The atoms didn't exist yet. The nucleosynthesis was a bit later. And that's the only way so far to study the very primordial universe. With gravitational waves, we will be able to get here, but with the next generation of interferometers, for the moment, only the LHC can go so close to study the universe. Of course, we work together with cosmologists, astrophysicists, astronomers, and also mathematicians who make the mathematics of the universe. And all together, we can say what we know about the universe. But what we know is not everything. I go fast. I skip all the part on medical applications and the applications of the technologies done here, because I want to tell you more about what we know with the universe and what we don't know. Because the bad news is that what we know is very little. So if you look at this image of a James Webb Space Telescope, obviously, what we are attracted to are the luminous objects. The luminous objects, these little specks, are all galaxies. Big galaxies, small galaxies. So there are tons of galaxies in the universe. We know them pretty well, thanks to the advancement in astronomy, astrophysics. But what we don't know is the dark. And the dark is the predominant part of our universe. So that's where the interest of contemporary physics, astrophysics, and cosmology goes. Because what we know is that galaxies rotate too fast for this rotation to be justified by what is observable today. Also, the movement of galaxy clusters is too fast. And there are other phenomena like gravitational lensing and the cosmic microwave background that tells us that what we know is not enough. And there is a mass that moves and justifies this acceleration that we don't see. Because what we see doesn't have enough mass. We see gravitational effects that are due to what we call today dark matter. Dark matter is let's say, the most credible hypothesis, but it's still an hypothesis, it's not proven yet. What we see is some gravitational effect that might be justified by a matter that is dark meaning that it doesn't emit any radiation that can be seen from our instruments that are working with electromagnetism. So basically, the hypothesis is that what we know for sure is that 5% of the universe is made of atoms. And this is the matter that we know, that makes us, that makes all the galaxies we see and we study, the interstellar medium, the oxygen we breathe, all the chemical elements in the table of chemical elements. We know that 27% is some sort of matter that is dark, opaque, doesn't emit radiation, and we know it exists because it has gravitational effect on everything else. But we also know that the universe expands from the moment of the Big Bang. That is pretty well known, and it's pretty clear that it must do that because the formation of stars and galaxies at the beginning of the universe is due to the cooling down and the expansion, gradual expansion of the ingredients of the primordial universe. But we also measured that this expansion of the universe accelerates. And this acceleration is not justified neither by the visible mass or the visible matter, nor by the dark matter. So the hypothesis today is that must be a dark energy that is prevalent in the universe, is the most important component of the universe, that justify the acceleration. But for the moment, we are like a detective on a crime scene. We know that there has been a crime. We have a few hypotheses. Some things we know, but most of it we don't know. We don't know who is the culprit. And the big challenges of science today are to find out dark matter and dark energy, if they are true or not, or if there is something else. And this is a challenge for all of you who are interested in science and want to do science. Please tackle this challenge and help us solve these two big mysteries of the universe. You can follow CERN on all social media platforms. We have a pretty good website, Home to CERN, where we find a lot of information. And you can also ask questions to me if you wish to know more about what we said. Otherwise, we can have a break and show a film that I shared with Corrado about what I do for Polar Quest, for my association. Up to you. It's a la carte today, and we can discuss more about CERN or take a break, show a film about Polar Quest and the exploration of the Arctic and the planetary boundaries of our planet, and go ahead. Corrado, I just ask you how we continue.
Can you hear us now?
I can't hear you very well. I can hear a background noise. I think it's better to share the questions on Zoom.
Thank you very much, first of all, for sharing your experience. I think that we can go on watching the video, maybe.
If I understood correctly, you would like to see the video?
Yeah, yes, please.
So Corrado has a video because sharing from Zoom doesn't work very well, especially with sound. Corrado, this is the video of Polar Quest. I can show you which one I mean. I can quickly share it to show. It's actually at the beginning of the presentation, after the image of Nanook and the iceberg, at the beginning of the Polar Quest part of the presentation.
Okay, thank you very much. We found it.
Very good. Grazie Corrado per il fantastico supporto tecnico. Possiamo tornare a noi, allo Zoom. Non so se avete visto il video, io lo stavo vedendo sul mio schermo.
Sì, abbiamo visto, grazie.
Ok, perfetto. Allora, adesso posso condividere di nuovo le mie slide per parlarvi di Polar Quest. Interrompetemi quando volete, perché sono a disposizione per domande e tutto quello che volete. Quindi questo è il video. Adesso per passare alla prossima slide. Ecco qua. Dunque, il video che avete visto è il pezzettino di un documentario che abbiamo realizzato dopo questa spedizione, la prima che ho fatto con l'associazione Polar Quest 2018, e in particolare il momento più bello della spedizione, dopo 6 settimane di navigazione fra la Groenlandia, l'Islanda, le Svalbard, oh, sorry, I'm talking Italian. I should continue in English. So, the video I just saw was a piece of our expedition, the highlight of our 2018 expedition. It's also part of a documentary. You see the link to the documentary here. It's available in English and in Italian. And it tells you about our 6 weeks on the sailboat Nanook, ecological sailboats, around the Svalbard archipelago. We started in Iceland, we continued north towards Greenland, then we circumnavigated the Svalbard archipelago, and we went as far as beyond the 82nd parallel on the edge of the polar ice shelf. And that part was at the end of the voyage, at the end of 6 weeks of navigation, where we had a fantastic encounter with a family of polar bears, a mom with 2 cubs, who were perfectly harmless because they were in their habitat. They were on an iceberg. The mom had just captured a baby seal. The youngest of her cubs was feeding on the remains of the baby seal. She was not hungry. We were not in danger. We were from our boat. We were at safe distance, like 15 meters on our boat, and they were on the iceberg. Absolutely not interested in us because we are not their prey. We are not their favorite prey. Their favorite prey are baby seals. And that was a fantastic moment of the entire expedition. This expedition is also the subject of a book. My book, Ottantesimo Parallelo, is not yet translated in English because I did not look for a publisher in English. I don't have time to do that, and my publisher didn't find a publisher in English. But if you do find a publisher in English, you're welcome to propose that to me. So we went to the Arctic. I don't know if you can see this animation. First of all, if you don't know where Svalbard or Spitsbergen in English is, this is the closest inhabited land to the North Pole. It's an archipelago that is well beyond the polar Arctic Circle, and it's a place where ancient expedition went, like at the beginning of the 19th century, to explore the North Pole. They didn't know until the beginning of the 19th century, 1926, basically, when it was for the first time overflown by Amundsen and Nobile. Nobody knew whether the North Pole was land or just ice. So we know today that the North Pole is just ice, sitting on the top of the Earth, on the summit of the Earth. We also know today that this ice, with its interaction with the sea, it's sea ice, frozen sea, that has seasonality. It does increase or decrease its surface according to the season, and it is responsible for the balance of the climate of the northern hemisphere, the hemisphere where we live, the hemisphere where civilizations developed in the Mediterranean basin. The melting of the North Pole, which is relentless and unstoppable, is a problem because it will make the conditions of our life, the life of human beings on this planet, worse and worse. The planet doesn't care if the North Pole melts, but we do have to care because our well-being depends on that. And unfortunately, the melting of the ice on the north is very directly correlated to the impact of our human activities, in particular to the excess of our activity, to the excess in warming the atmosphere with our emissions, to the excess of waste, of the plastic waste, single-use plastic especially, that is more abundant in the ocean than the quantity of fish in the ocean. So what you see here on this animation, this is a satellite that monitors the North Pole since 1975. You can see that the seasonality is pretty normal at the beginning of the era, But if you do an average after 2020, the melting is relentless and unstoppable. This is just to show the north of Svalbard and the 82nd parallel north that we reached with our boat. We were going on the tracks of Airship Italia. Airship Italia was an airship that in 1928 wanted to explore the North Pole after having overflown the North Pole. The same people, Nobile and Amundsen, in 1926, they wanted to land on the North Pole and study it. So Umberto Nobile was an Italian aeronautical engineer who built first the Norge airship, with which he went with Nobile, with Amundsen in 1926. And in 1928, he, on a second expedition, leaving from Svalbard, he went again on the North Pole, but they couldn't land because it was very bad weather. So they overflew the North Pole for a couple of hours. They took photos. They wanted to study it, study the currents in a very visionary effort to understand the melting. They had understood it was just frozen ice, and they understood this frozen ice had a very important role in the balance with the atmosphere, the exchange, and the parameters of the salinity of the sea and the currents and so on and so forth. So they had a big payload of scientific instrument. Basically, the Airship Italia was the first Skylab of history, but because of bad weather, they had to go back towards Svalbard, and on the way back, they crashed. A piece of the airship fell on the ice pack, and the balloon, the floating part, left with 6 people on board who were never found back. The 8 people on the ice were rescued after 7 weeks on the ice in a miraculous search and rescue operation from many nations. And in the end, it was the Russian icebreaker Krasin which rescued them, thanks to the small camp radio that they put together and made to function, and they sent SOS. So together with a few colleagues, I went to look for the Italia airship. We reached the SOS, the first SOS point, which was given on 24 hours after the crash, which was on the 81st parallel north. And then, since there was no ice, we said, let's go to find the ice. And we sailed and sailed 100 more miles. And we finally found the ice on the 82nd parallel north, which is not normal. Normally, the ice is much closer to the northern Svalbard. But in 2018, it was very deglaciated and we could sail. We could do a search and then we continued south. This is a photo of the Airship Italia on its departure from Svalbard in April. When we left Svalbard with Nanook, there was no ice at all. It was completely deglaciated. In Svalbard, last year, for the first time, they had summer temperature of 15 degrees. It never went beyond 5 until a few years ago. And this is the Norge, which is the twin of Italia. This is Nanook. I don't know if you can see. Here we are sailing along the largest ice glacier, the largest glacier on the northern hemisphere, called Austfonna, on the northeast coast of the northeast island of the Svalbard archipelago. 200 kilometers of continuous glaciers that are constantly calving, meaning losing ice. You can see here one of these calvings. You can't hear the noise. It makes like dynamite explosion. And it's quite dangerous to approach because they make a tsunami wave. We had this all along the 200 kilometers of the ice shelf of the glacier. And this is very bad news because ice that goes in the sea changes the salinity and temperature of the sea and changes the conditions for the living of the animal, of the sea animal and the sea life, from phytoplankton to zooplankton, to whales and big mammals that live in the sea. And it changes the current. So it changes all the parameters that basically balance our so far nice climate that could create the conditions for life. We went there on purpose with a small vessel, Nanook, made for the Arctic, but also ecological, with zero emission. We didn't have heating. The Nanook is made with passive architecture. Of course, like on every sailboat, especially in an environment that is so wild, where there is nobody that can supply you with what you need, food, water. We have everything on board. So we had passive architecture that made us use our human heat to heat the inside of the boat. This is a boat that has solar panel and aeolic wind power plant on board. It could survive 8 months in Greenland, including in winter, on itself, by itself, with the means of the board, with minus 47 outside. And on every sailboat, you need to save and to ration your resources, and in particular if you are in the wild like this. So on our what we call passive igloo, which is the Nanook, the boat, we consumed 30 times less water, energy, food, everything than we consume at home. And we did not feel uncomfortable. We had a lot of food. We consumed maybe 30 times more food because we had a lot of food on the boat in a natural fridge because the temperature of the sea was 3 degrees and our natural fridge was the bottom of the boat where we put all our food. But we were not feeling uncomfortable. We were actually feeling very well inside Nanook because outside we were actually in the middle of the wild. I have to confess that my first shower when I came back from 6 weeks without shower and hot water, I only had hot water from the teapot on a glove, you know, and I washed everybody washed ourselves with the glove with hot water from 1 cup of tea, equivalent of hot water. But that was a luxury, but we didn't feel uncomfortable. So what we think is that everybody at home, I don't say you don't have to have a shower, but have less showers and try to produce less waste. And that's already a big gesture for improving our living conditions on the planet. This is the crossing of the 80th parallel. Somebody before asked what was the most exciting moment of the adventure. For me, it was when I saw this on the plotter of the boat. The blue part is beyond the 80th parallel. So you can see that we are about to cross the 80th parallel. We have 79 degrees north, 58 and 293, which means in a few moments we cross the 80th parallel. The 80th parallel is the line that separates us from the unknown. Everything below is charted. Everything above is uncharted. And for me, it's very exciting to go into the unknown, to go into uncharted territory. And that was the most exciting moment of the expedition. Of course, it's risky because you have to sail on site. You have to know where you're going at every single moment. The nautical charts don't help you. They're not reliable. And you have to be prepared for every risk. You have to have a metal hull, and you have to avoid all the iceberg. Even the compass don't help you very much at such high latitudes. GPS doesn't work. You really have to navigate as in the 1600s before. The sextant works, but it's very foggy, often foggy. So in order to measure where you are with the sextant, you need the sun. So you have to be prepared, but it's extremely exciting. And accident can happen. Like we didn't have on the chart these rocks, and at low tide, we got into the rock, breaking a mobile board, central board of the boat, but we repaired it. We had a second one. Everything was redundant. So we were basically 12 hours stuck here. And when the tide came, we could move. You have to watch for polar bears because Spitsbergen is the territory of polar bears. They are the masters. As you saw in the film, when they are fed and they are in their environment, icebergs, they are not dangerous, but unfortunately there are less and less icebergs and they become dangerous. So you have to have somebody on watch all the time. You have to have weapons. You have to have flares, and you have to be trained when you sight a polar bear what to do. You have to try not to kill one and only resort to the rifle when they are attacking you frontally and they are 100 meters from you. But that means you have 2.5 seconds to put him down. And you have to really avoid these circumstances. So how to avoid is to have somebody on watch and always look around that there is no bear when you go on land. Because they can be extremely dangerous. They are a very large predator, the largest predator. They can be up to 800 kilo and 3 meters tall. They run faster than you, 40 kilometers an hour. They can swim and climb everywhere and faster than a human. So it's better to avoid encounters with bears. Oops. There are accidents. Unfortunately, often is the bear, because you go with guides and you go with rifles. But every now and then a human loses their lives or loses their fitness, because the bear can make you handicapped very, very quickly. But if you respect the environment and you don't go to disturb them, and they are fed on the iceberg, they can be as friendly as they were on this iceberg. Of course, we didn't approach the iceberg, but we were 15-meter distance and very silent. Let me go further. What we did during the expedition, we reached the polar ice shelf. We measured cosmic radiation as close as possible to the poles. We sampled microplastic in the sea all along the trip, including on the ice shelf. We mapped the coast in 3D, because the northern coast of Iceland are not mapped. And we also measured the depth of the sea by adding a few values on the nautical charts that nobody ever measured before. So it was a very, very fruitful research expedition, in spite of the low impact, the low cost, and the low means that we had compared to big research expedition on big vessels. We used citizen science to make our instrument. We involved the young students from Italy, Norway, and Switzerland to put together the cosmic detector that we brought on board, and also to measure the data, to analyze the data. We put the data together. Two young students, 18 and 20-year-old respectively, were trained in our research lab, marine research lab in Italy, in La Spezia, to be able to sample microplastic and to prepare the samples for analysis. We are among the very, very few scientific expedition which managed to sample on the edge of the polar ice shelves with the manta net. This is how you sample. You drag the net, then you take the filter, you put the position, you don't contaminate the sample with gloves. And then we saw a piece of visible plastic visible to the naked eyes during the sampling on the polar ice shelf. We saw plastic all along the trip, everywhere, on each desert beach that we landed on. We were on some beaches, the only humans which were there, and we saw plastic everywhere. We found two dead reindeers. Their antlers were entangled with fishing nets made of plastic, and they probably died because of that. We saw a big plastic tank with a bite of a polar bear. It came from Italy. It was in the 80th parallel. It came from Italy, or at least it was produced in Italy, because there was a text on it, made in Italy. So plastic was everywhere. And plastic is brought to the Arctic from the currents, the sea currents. And because there is nobody there, it's not collected, and it ends up in the sea, and it becomes microplastic, which is very dangerous. It's plastic invisible to the naked eyes, plastic that ends up in the stomach of zooplankton and whales, or in the phytoplankton, the basis of the food chain. These are the results of our analysis, which were published. M stays for manta. Manta sampling 1 was done, you can see it on the west coast of the Spitsbergen. The manta 4 was the northernmost one on the polar ice shelf, and it was the fullest of microplastic, because the North Pole ice shelf acts like a barrier, and it keeps the plastic where it hurts more, because that's the most fragile and the most important area for the balance of our climate. So nowadays, maybe you've heard about the first meeting at high level of all the nations to get a global plastic pollution agreement, like the climate and the global warming agreement. These are political meetings. Of course, scientists participate and give their contribution, but it's very difficult to reach political agreement. Although it's a very good initiative, they didn't reach any conclusion at their first meeting. There is a second meeting foreseen now in 2025. But we cannot wait for the legislation to change, to do something. We have to do something today. And something, although it's very difficult to stop fossil fuel emission, okay, we can all take the bicycle to work, okay, we can all try to use the car as little as possible, but it's not, what we can do individually is very difficult. It's at the level of industries and governments to change the way we consume energy and we produce energy. But we can do a lot for plastic. We can start stopping use single-use plastic, because that's the highest quantity of plastic that ends up in the oceans and on land as well, that is contaminating what we eat, what we breathe, what we drink, really in a very serious manner. So we can stop using single-use plastic before it's becoming forbidden because of legislation. We can reduce, we can circulate, we can try to recycle our waste in general, but especially plastic, and go towards circular economy. Because pollution, because plastic recycling is not efficient, is something that can be done, is done at very low level. It's done only 9% of the plastic is recycled. Not all the plastic can be recycled. For instance, the black plastic cannot be recycled. So let's not buy black plastic container of shampoo because they are cool. All shampoos are the same. Let's try to use, let's try to refill as much as possible our products. So what was I saying? This is going backwards. So myself, I've bought this boat, Lady Magellan. I've created a fleet of sailboats with Polar Quest. And as of this summer and more in the next years, we are trying to work for science to get more data from the sea, because data from the sea are very little. The sea is enormous, is 89% of the surface of our planet. So we need data from the sea. So we are putting our fleet at disposal of the scientists, but we are also giving the example and doing action to create awareness that we need to change. We need to transform the way we live on this planet if we want to keep our life comfortable and our planet beautiful. The planet doesn't care if it becomes like Mars, but we, as a human species, we do have to care, otherwise we are going to disappear. And it's in our interest to become more sustainable and to do our little action every day towards sustainability. Follow Polar Quest on social media. We are everywhere on social media, and we have started being active again, and we will never stop. Thank you for your attention. And I don't know if there is more time for question.
Thank you very much. So they're really interesting. We have no questions up to now.
I can hear just a background noise. I heard you have more questions or no more questions?
And no more questions, just
okay.
one.
Just one?
Plastics. How can we do in our everyday life?
Can you write? I really don't. There is too much background. I don't hear the questions. Can you write them in the chat or on my mobile?
Sure. How can we contribute in reducing plastics? In our everyday life.
Anche se non ci sono loro nel video. The question is, how can we contribute in reducing plastic in our everyday life? Don't buy anything with plastic. Don't buy plastic bottles, carry a permanent bottle. Just don't buy single-use plastic that you use once and you throw away. When you go to the supermarket, don't buy fruit and vegetable wrapped in plastic, but buy them just as individual fruit. If you can, go to refill shops for your soap, for your shampoos, for your bubble bath. Just try to reduce every good that you consume that has plastic that doesn't last at least 5 years of your life or 1 year of your life. And also become an activist. There are many, many apps to which you can give your contribution. You can document plastic on beaches. With your app, you take a photo and you fill in a very simple questionnaire, and your data go to the scientists who study plastic and who understand what's the most damaging plastic, what type of plastic it is. Become aware that it's difficult to avoid plastic because it's everywhere. But if you don't consume it, for instance, when you buy Coca-Cola, rather buy a can. Coca-Cola is the biggest polluter of plastic in the world. Fast fashion, yes, absolutely. Avoid shine, avoid fast fashion. Buy less clothes, but good clothes, good quality clothes made of cotton, made of wool and cashmere. It is absolutely true. Fast fashion is a very big polluter. That's another thing you can avoid. You can be beautiful without changing your clothes every day. You can be beautiful with clothes that cost a little bit more. You buy less, but higher quality. These are things that we can do on a daily basis, and become also a messenger of this message around you on your social. Nowadays, everybody can be an ambassador using social media platform. And be careful, be aware of what's happening around you. Take the news from science on this field, environmental science, very seriously.
Abbiamo altre domande, raga?
Quale sarà la tua prossima spedizione?
What will be my next expedition? Yes, I got that.
Now it works.
I have many expeditions. So, as I said, with my association polarquest.org, you can check online all the boats that are in it and where they are. I have boats in the Pacific Ocean who are going to document mangrove and also to replant mangroves, because mangroves are very good plants that hold the coastline. There is a lot of loss of coastline, and coastline is very my own boat and a few others. We are documenting the DNA of Phoca monaca, the monk seal. The monk seal is a mammal that was prevalent in Mediterranean and is very good for the balance of the Mediterranean, but it's becoming an endangered species because of overfishing, but also because of the warming of the temperature of the Mediterranean Sea. So spotting the monk, just as scientists did before, by just looking, because the monk seal is a mammal, she comes out of the water to breathe, but you don't see all of them. And she's also very fast swimming. So you can spot the same monk at different location, and you might be false in your data. So we're doing eDNA, environmental DNA, because this mammal is quite big, and she leaves her DNA in the surface of the sea through her feces, through her breathing, through her reproduction. So it's very easy. And this DNA of the seal, also from the skin, it stays in the sea for a few weeks. So by collecting sea samples from boats and then filtering them and giving the filters with the DNA of the monk to the lab, and by collecting the samples, many boats at the same time on the same day, you can be sure that the DNA each boat sample belongs to a different animal. So we can have a count. Not only a count of the seal, but also see if they are healthy, how old they are, male, female, cub, pregnant, not pregnant, and then we can have an assessment of the seal. Also understand where they are more numerous, which means that the conditions for feeding and for reproducing, they are the best for them. And in the end, with this study, we can determine the best areas of sea to protect and to transform into marine parks. So this shows you how from research with DNA, environmental DNA, you can get to identification of the best area to protect. And yes, you can follow these expeditions from our social media. So Polar Quest social media, I can share the last slide that I shared with you. We are on this platform where you can follow us. And we will do lives. We are just starting these activities. And since I'm also working at CERN, we cannot do this full time. But already this summer, you will be able to follow. And in any case, through the social media, we keep you up to date. We will do lives from the boats. We will do lives from the labs where the samples are analyzed. And we are also preparing a very big expedition for 2026, 2027, to go again in Svalbard to search for the airship. And that would be a major thing. But we have many, many more. So I just quoted the two that we are preparing right now, the mangrove in the Pacific and the DNA of the monk seal in the Mediterranean. Shall we call it a day? I think you're all hungry, want to go to lunch? Yes? No? There's something else in the chat. Yeah. So polarquest.org and our social media will give you all the information you need. And we do lives as well to explain what we do with the expeditions. Corrado, ci salutiamo?
Ultima domanda.
Ultima domanda, ok.
Stiamo scrivendo.
La spedizione di Patagonia.
Sulla Patagonia volete sapere?
Sì, grazie.
C'è una domanda specifica o in generale?
Come è andata l'ultima spedizione?
Okay, so Patagonia was a small expedition because I was working full-time at CERN. But I joined the boat of a friend who is an astrophysicist and who does now, because he's just retired as a professor at the University of Geneva, and he's also a sailor, he's circumnavigating the whole Earth on his boat. With the boat is called Gaia. I will write the name, like the name of the ancient name of the Earth. So you can follow him as well. And Patagonia is very difficult to navigate. Since I'm an expert sailor, he asked me to join on board, but also to do some communication. So we navigated from Ushuaia, which is in Argentina, on the Atlantic side of the Southern Ocean, Southern Atlantic, to the Pacific through the Magellanic channels. So instead of doing Cape Horn, we crossed through the channels. It is equally difficult as the Cape Horn. Cape Horn can be very stormy, but if you wait long enough, you can get a good meteo spell and go. But in the Patagonia Channel, the meteo, the weather forecast is very difficult and is very unreliable because these channels are like a labyrinth of fjords. And the GPS doesn't work. Compass is sometimes getting crazy because you're close to Antarctica, and the winds can be extremely strong and unpredictable, and you have a very little space to anchor your boat, and you have to attach your boat with 6 different lines to the Earth. The most interesting thing that I saw in Patagonia were the fight between glaciers that from the Andes that end up in the sea, and are actually the only glaciers in the world that are increasing their mass. Because it rains a lot, and because it's cold, and because there is the Humboldt current from Antarctica, this rain becomes ice and feeds the glacier. So these glaciers are sort of fighting with the jungle. So you see at the same time, jungle and glaciers. And it's quite an amazing phenomenon to see. The other thing I saw is that the indigenous population have less and less resources from the sea to be able to live there. And they are abandoning the villages, the few villages that there are, because they cannot fish anymore. There is overfishing, especially from industrial fishing, especially salmon. There are Norwegian factories that fish from there and sell the salmon as if it was Norwegian salmon. But it's not true. They actually, and it's not wild salmon. They do aquaculture, and they use fertilizer, and it's extremely polluted. And actually, these areas are guarded by military. We wanted to approach to do some investigation to take photos, but we were kicked out by the Armada del Chile, and it was quite adventurous. But it was, again, what are we doing to our planet in order to earn more money? This is always the equation. If money is our guiding principle, everything goes bad. Everything. Politics, peace in the world, environment, and so on. If we are guided by science, we do things well and in a rational way. We do everything together and we collaborate, and we also appreciate what we get much more than if we are spoiled and we can get anything we want anytime. So I think this is a good message to close the meeting.
Yes,
And I thank you for your attention. Thank you for your technical support, especially my team here, Ron, Melanie, and Chetna. Come here so we can see you as well.
Next,
Voilà. And Ron, thanks a lot. And follow CERN and follow Polar Quest. Bye. Bye-bye.